sample statistics and population parameters. So sample statistics, those include the mean and the standard deviation. And population parameters, those also include the mean and the standard deviation, but we have Greek letters for those instead of English letters. Okay, now suppose that from a population of size capital N, all right, capital N, that's going to be the population size, we draw all possible samples of size lowercase n, right? Lowercase n is our sample size. So we've got a population, and now just theoretically, we're going to draw all possible samples of some particular size, small n. Now, for each one of those samples, we can compute a statistic, such as x bar or s. Now, these values will most likely vary from sample to sample, right? They're not all going to be the same number. So from sample to sample, we're likely to get different values. And from those, we can obtain a distribution of that statistic. Now, if x bar happens to be the statistics that we're using, we get what is called the sampling distribution of the means. Now, what we're doing is from a population, we're taking all possible samples and computing, say, the mean. All right, so we've got all these means. Now, what we could do with all those means is we could actually find the mean of those means. So here's some notation. And we have all of them, so we actually have mu. So what we have is this. We have the mean of, now I'm just going to use the subscript to name what I'm taking the mean of. We have the average of all those averages, right? So we have the mean of all the means. Here's what this says. This is the mean of the means. And if we took the standard deviation, if that was our statistic, we could write this, the standard deviation of all those x bars. All right, so we can get the mean of the means, and we can get the standard deviation. All right, this means the standard deviation of the means. Now that's really a whole lot of words. Let's draw a picture, and I think it'll make more sense. So here's the relationship between the sample means and the population parameters. Now, remember what we're going to have. We're going to have a population of size capital N, and our sample sizes are going to be small n. What we're going to do is, I'm going to draw a picture here. We're going to take a population. Okay, I'll draw it like this. Here's the population. And, all right, so this is our population. See if I can spell it here. Population. And so, you know, we've got all these x values, right? All the values of the data. We've got maybe like x1, x2, x3, dot, 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 up to x sub, now it's capital N, because we've got n pieces of data, right? So we've got, you know, the first piece of data, the second piece, the third piece, dot, dot, dot. And we've got the nth piece because the population is size n. So we've got every piece of data here. And then, using all these data values, we can find the mean, right? Now, the mean is mu, because we have the population. And we can find the standard deviation, which is sigma, right? So remember, when you have a population, we use the Greek letters. Now, here we go. From this population, we're going to take every possible sample of a particular size. So what we're going to do is, maybe we do this. We take a sample, all right? So I'll draw it as a circle here. So this will be sample 1, and let's see, the size is small n. And then out of this sample, I compute x bar. Okay, that might be like x1 bar, the first mean, the mean of that first sample. All right, then we take another sample, same size. All right, that might be sample 2, size n, and we compute the mean. So I get x bar 2, right? The second mean. I do it again. All right, but now this is sample 3. and the size is n, and once again I compute x bar, so I compute the third mean, okay? And then dot, dot, dot. We just keep doing until we get every possible sample. All right, so this would be sample. I'll just call it the last sample. Every possible sample we're going to take, here's the last one, right? So dot, dot, dot. Now, this is also size n, and this will be x sub, last bar, all right? That's the last sample, and we compute the last mean. So what we've got here is a population, and from this population, maybe there's 4,000 people in this population. We're going to take samples of size, say, 100. So I take every possible sample of size 100. Okay, now, there's a lot of them. In fact, you might remember how to do that when we did our counting in combinations. If you have a population of size capital N, how many are there? Small n, right? There's this many. So, we were doing things like this. If I had a population of size 60, how many possible samples are there of size, say, 16? Okay, it would be that count there. So that's what it is we're doing. From a population of some size, we're taking every possible sample and computing the mean. Now, I got all these means, right? We've got all of these means. I got that mean, the first one, the second one, the third one, dot, dot, dot. I got the last one. So what is the mean of all the means? It's like, what's the average of all of these sample means? Well, this is going to be, we know how to compute this, right? This is going to be, what do? We add up all of the x bars and divide by how many we have, okay, by the total number. Now, as it turns out, this fabulous thing turns out here. Here's what this means. This turns out, all right, here's the notation. It's the mean of all of the means, and that happens to be the exact mean of the population, okay? So if you take the mean of all the means, it turns out that that is the exact mean of the entire population, meaning this, all right? Here's the entire population. Take every possible value, add them up, divide, and you get the mean. That's mu. But if you do this, if you take every possible sample, compute the mean of every sample, and find the average of all those, you get exactly that same number. And I'm just going to say it here, that the standard deviation of all those sample means, I'm going to write it like this, standard deviation of all the sample means, well, that turns out to be, now, it's not just this, okay, it's not just that. Slight difference, what it turns out to be is this. It's going to be the standard deviation of the population, but divided by the square root of the sample size. Let's look at some examples. So first up, how about this? Can you give two examples of a population? Well, I've written two here. Might be the ages of all students at a college, right? So you have all students at a college, you just you just look at their ages, and you might even think of the cholesterol levels of all the students at a college. So another question here, what's the population parameter? So I'm going to write an answer. I'm going to say it's a measure that describes some characteristic of a population. Now, there's several things it could be. It could be the mean, right? It could be a mean. Now, it's a parameter, so it's going to be mu. It could be a standard deviation. Parameter, so it's going to be sigma, right? Parameter, so Greek letters. And it could be actually a proportion. Now, we haven't talked about these yet, but we will. And I'm going to, now this is just going to be a P. For parameters, we like to use Greek letters, but for proportion, oftentimes you'll just see an English letter. Although I have seen a Greek letter used like this. What would you use for proportion? Like a letter that starts with P, so I have seen pi. Some people use pi for that. But we're just going to use P. All right, so these are population parameters, and parameters are just measures that describe some characteristic of a population. Right, the average, the amount of spread, and proportion of something. All right, here's another one. What is a statistic? Well, it's going to be, I'm going to say it about the same way I did for a parameter. It's a measure that describes some characteristic of a parameter. You measure the characteristic of a population. For statistic, we measure a characteristic of, you can fill that in. What do you think it is? It starts with S and ends with E. And it could be, it could be the mean. Now, so statistic, what letter are you going to use here? Standard deviation, what letter are you going to use here? Now, for proportion, even though we haven't done this, for population, we're going to use the P. What we're going to use here for proportion is this. We're going to use a P, but I'm going to put a hat on it. So that's called P hat. All right, and that is what we use. That's the symbol we use for a sample proportion. What is a statistical inference? What we're doing is this. We've got some population that we're interested in making a statement about. So we take a sample, and from that sample, maybe we compute the mean. Now, we're going to use the value of that mean to make a statement or draw some conclusion about the entire population. So I'm just going to say it this way, that statistical inference, that's a conclusion that we make about the value of some parameter, right? So we're going to make a parameter, say, is something about the entire population.